Hello, ladies and gentlemen. We're going to look at trigonometry applications or applications of trigonometry. There are lots of those, one of which is angle of elevation and angle of depression. Anytime you see one of those two phrases, I would recommend that you sketch a rectangle, all right, which is what I'm going to do, all right, and then put in one of its diagonals, because if you do, you have an angle of elevation down here at the bottom, and you have a congruent angle of depression up here at the top, all right, where the diagonal ends. Okay. All right, and excuse me. So this is an angle of, down here is the angle of elevation. And up here, that's this angle right here. And this angle right here is the angle of depression. All right. Now, of course, if we are wanting to solve a problem with angle of elevation, this will work just great. When you look up from your normal line of sight, your new line of sight form an angle. Your normal line of sight and your new line of sight will form an angle of elevation. All right, when you look down, your normal line of sight and your new line of sight will form an angle of depression. All right, so let's look at example number one. Example number one says, an angle of elevation from a sailboat to the top of a 120-foot lighthouse on the shore measures 16 degrees. To the nearest foot, how far is the sailboat from the shore? Well, once again, I'm going to just sketch a rectangle, and I'm going to put in one of its diagonals. All right, and I'm going to call this rectangle ABCD. All right, and if we're in a boat, we would probably be down at point D. We wouldn't be looking downward from point B. We'd be down where D is. So point D would be the sailboat. Oops, sailboat. All right. And point B would be the top of the lighthouse. Okay. And the angle of elevation is angle CDB, and it's 16 degrees. All right. The lighthouse itself is 121 foot. All right. And that's segment represented by segment BC, 121 feet. All right, and what we are looking for to the nearest foot is how far is the sailboat, which is point D, from the shore? Well, that would be over here at point C. Okay, so we're looking for, if you like, DC or X, whatever you want to call it. All right, well, when I look at that, here's my acute angle in right triangle DBC. It's the angle DBC. I notice that I know the side length opposite, and I'm looking for the adjacent. So I need to ask which trig function deals with opposite and adjacent. Well, it's not sine because that has hypotenuse. It's not cosine because that has hypotenuse. So it has to be the tangent. So I'm going to write my tangent equation. So the tangent of 16 degrees, the acute angle measure, is equal to the opposite leg length, which is segment BC, or the 121 feet, divided by the adjacent leg length, which is segment DC, which is represented by X. Okay, so now I would make a proportion out of it, and I would ask, what does X get multiplied by? Well, X gets multiplied by the tangent of 16 degrees. So I'm going to write that down, and that's going to be equal to the other cross product, 1 times 121, which is 121. And then I would need to go ahead and divide both sides by the tangent of 16 degrees. All right, and on the left, the tangents of 16 degrees would cancel, and I would have exactly 121 divided by the tangent of 16 degrees. Now, the only thing I would need to do, since it wants me to the nearest foot, is put that in the calculator and round it to the nearest whole number, because that's what the nearest foot would be. Now, please remember, anytime you're doing trigonometry, you need to make sure and you see a degree symbol, you need to make sure you're in the right mode, which I am. If you're not, go to the word degree and hit enter. Okay, that way you can make sure. And now I'm going to type in 121 divided by the tangent of 16 degrees. And when I do, that would round to 421 or 422, depending on this digit to the right. That's one of your 5 highest, so it'll go 422 feet. So we're talking about x is approximately 422 feet, or if you like, this boat is approximately 422 feet from the shore. Okay. All right, so there's your work for example number 1. All right, let's look at example number 2. Example number 2 says a ladder leaning against a wall just reaches the ledge 40 feet off the ground. If the ladder makes an angle, 70-degree angle with the ground, how long is the ladder? Well, I'm going to sketch a building. Okay, so here's a building. Okay, here's the ground, if you like. All right, we don't need all that below. And we have a ladder going up to a ledge. Okay, so segment AB represents the ladder, and that means that since the building is erected perpendicular to the ground, that triangle ABC is a right triangle. And the ladder, which is segment AB, makes a 70-degree angle. All right, that would be this angle with the ladder and the ground, 70-degree angle with the ladder and the ground. Okay. All right, and we know that segment BC is 40 feet. And what we're looking for is how long is the ladder, which is segment AB itself is what we're looking for, okay? All right, and really, technically, all you need is that right triangle. You don't have to have all the other stuff, but if you have more, that's okay. Better to have more and get it right than not enough and miss it, okay? All right. Well, if we're talking about this acute angle measure, this 70-degree angle, we need to figure out what I like to do is figure out what's not involved. I'm not looking for the adjacent. So I would go and say, if I was doing SOHCAHTOA, which one does not have an A in it? Well, it's not cosine and it's not tangent because they both deal with the adjacent. It's the sine. That's how you can figure out which trig function to use. All right, so I would do the sine of that 70 degrees is equal to the opposite leg length, which is 40, divided by the hypotenuse, which is x. All right, and once again, make a proportion out of it. What does x get multiplied by? Well, that's the sine of 70 degrees. So x times the sine of 70 degrees will be equal to the other cross product, all right, which is 40. And then we just need to solve for x by dividing each side by the coefficient of x, which is the sine of 70 degrees. Okay, so we divide by the sine of 70 degrees on both sides. These sines of 70 degrees will cancel on the left, and x will be equal to 40 divided by the sine of 70 degrees. All right, there's your exact answer. All right, and then we will just type that in. 40 divided by the sine of 70 degrees. And when we hit enter, we see that that ladder would be, and did it say round anything? No. Well, if it doesn't say round, I would always like for you to round to at least 2 decimal places. So let's round that to 42.57 feet. So x would be approximately 42.57 feet for the length of that ladder. All right, now, that's all we have for today. If you have any questions about any of the trigonometry applications, please give me a call, email me, or show up in a Google Meet. And you have a good day. Thank you. Bye.